Okay, one final thing to try to grasp, let's say mess with your mind at least a little bit. That is what's called a stratified sample. All of this up to now was about you have a big population somewhere and we're sampling from that at random. Now, one question could be, especially given that we get such large numbers, couldn't we do any better than that? And there is a way to do better. If you can stratify your sample in different kinds of groups. So let's suppose that we have, let's say for ease of exposition, two groups, males and females, just as an example. But you could, in principle, generalize this to way more groups than that. Then, if you go through the math that belongs to this, we're not going to do anything in Stata with these kind of things, but it's good if you at least remember how this works, because as soon as you need to actually collect data yourself, this one can save you a lot of time and energy. If you can divide your sample in, let's say, two groups, then you will see, if you do the math or follow the math from somebody else, that the actual sample size necessary from that particular group depends on two things. On the size of that group, and this is where it starts to get weird because the population size at first didn't matter, but for stratified sampling it does. The size of that group and the variance in that group. Okay, the variance is easy to understand. If I have a group here, males, for instance, and they do not vary a lot. I want to ask you a question and there is no variance or hardly any variance in that answer, then I would be, why would I ask 1,000 males if I get no variance? They're all saying 3. If I know that the variance is small, it would be weird to put half of my sample in the male group. Okay, so the variance is low, and I want to have as low samples as I can get away with. If I have something that is really wide in terms of variance, everybody says something else. Then to measure that appropriately, I need to have a large sample. Okay, so that's the thing to go by. If you look at different kinds of groups where I have K, and you have an estimate first of the size of that group in the population, here labeled NK, and an estimate of the variance on whatever it is that you want to measure of that group in the population, and you take the product of the two, and that itself is your measure for how large of the sample should be in that particular group. And that will certainly help a lot in trying to get the sample size in the end down or the precision up, whatever it is that you prefer. But of course, what you need for this is that you have a group for which you know the variance in there is not very